Hi everyone, thanks for joining us for our ADF and Biml webinar. We have our nice slide here with the transition. So today we're going to be talking about specifically Azure Data Factory V2 automation and how we can do that with Biml. And in BimlStudio specifically, which we're going to be doing most of our demoing, but we are going to talk about what this looks like in Biml Express going forward as well. Please do, over the course of the webinar, if you have any questions, go ahead and just post those right away in the questions window in your GoToWebinar panel. And if I can, I'll answer them as we go. If they're relevant to everybody, I'll go ahead and answer them actually as we're going through the flow of the presentation. And if there's something more specialized or I just can't kind of weave it into what we're already doing, I'll make sure that every one of the questions gets answered either verbally or in writing by the time we wrap everything up here. My name is Scott Curry. I am the CEO of Verigens and the original creator of Biml, and I have been leading the development effort on bringing Azure Data Factory into Biml. It's actually been quite an effort. There's a lot of surface area and a lot of new surface area in particular with Azure Data Factory V2, and it's been very exciting to figure out the best ways to map that into the Biml language and the Biml kind of automation ecosystem. So it's exciting today to give everybody our first public deep dive into what that functionality is going to look like. Those of you who are at the past summit or who may have watched the keynote saw that we did our announcement of that during the past summit keynote. But we only had a couple of minutes, as is usually the case with keynote demos, in order to show you just a very high-level overview of how the workflow would operate. But here we're going to get right into the weeds and show you what the language constructs look like and how we do things a little differently than is done in the native ADF JSON and why that all makes sense. So let's go ahead and jump right in. We are going to first look briefly at how Biml worked with ADF previously, because you could actually do ADF automation with Biml. Megan Longoria actually has a series of blog posts on that, which are excellent and a great read, where you actually use Biml script to author JSON, and then you have a system where you write those Biml script outputs to the file system directly. So you're kind of using Biml in the utility libraries and the programming constructs so that you can do that ADF automation, but it was clunky in a lot of ways. It was very much a workaround to having a real solution. But we are going to discuss briefly kind of how that worked, and there are a couple of reasons why that makes sense. One is if you have existing ADF V1 solutions with Biml, and we know Megan's not the only one who has it, you'll have a little bit of insight into kind of how that worked before and how that transition is going to look. And of course, for those who don't have a previous ADF solution, the techniques that are used in that approach are still actually very useful in other contexts, so it's worth taking a look at how you can actually build a solution that works that way. But then we're going to spend most of our time in how Biml works with ADF V2 in the upcoming release and how we've fully modeled everything that is in Azure Data Factory as first-class elements in the Biml language, and that you can interact with very easily. And of course, because it's Biml, we also have some extras which are specifically designed to make it easier to do automation sort of tasks in a scripted workflow. So I'll give you a little peek into one of those just as a preview. We have, for example, a feature called dependency mode, which lives on all containers, and just like constraint mode for SSIS containers that would automatically create precedence constraints for you in a scripted workflow, this automatically creates activity dependencies. Just one example of many of the things that we can do, and that's also an area that we're looking for additional feedback. That's going to be a moving target. ADF is fairly new, certainly relative to integration services, and over time, the platform is more of a moving target as well. So some of the things that we do as abstractions today might become part of the core platform in the future, and some of the things that, as the core platform changes, that would be made easier by new language additions, we'd love to be able to pull those in. So anybody who has insights on those, we're very open to hearing about that. Okay, so how did Biml work before ADF and V1? Before we kind of jump into that, I just want to get a kind of pulse of the room so that I can maybe target and adjust based on what people's experiences are. So we have this great polling feature here in GoToWebinar. So I am going to select a poll, and it's going to be first, have you used ADF before? And the questions, the answers are yes, but just in V1, yes in V2 with the preview, yes in both V1 and V2, or no, not at all. Okay, so it looks like we've got about half of the room as the numbers are rolling in here saying not at all, about a third of the room saying yes in V1, and we have about 9–10% of the people who use it in both V1 and in the V2 public preview, presumably the public preview, and 6% who are yes in V2 only. So that's great, and I'm just going to use that to gauge how much sort of backgrounds information I give on bits of terminology. Since there's a lot of folks who are new to ADF here, I'll try and do my best to make sure I don't leave anything unexplained. So I'm going to go ahead and ask you the second question, which is, have you used Biml before? Yes, actually with ADF, yes, but not ADF, and no Biml. This will be either you've seen presentations before but haven't done it, or maybe this is the first time you're seeing Biml at all. Okay, we've got most people in, and looks like nobody has used Biml with ADF yet, and we've got about 2/3 who have used Biml before, and about a third who haven't. So that's great. All right, let me go ahead and close out that poll as well, and we're all set. Good. So this should be useful then. How did Biml work with ADF before? If you were still doing V1 workflows, and perhaps you're going to be locked in to V1 data factories for some amount of time and can't transition immediately, for those of you who have used, who are currently using ADF V1, could you use Biml with ADF V1? All of the stuff you're going to see in the V2 language features are not going to be available for V1 targets. V2, for those who aren't aware, has a very, very large number of breaking changes, and we're actually going to have a short coverage of the breaking changes a little later in this presentation. So the question became, do we try and support V1 and V2, which are incompatible in some fairly important ways, or do we just say, hey, look, we're going to do a reset and support V2 only with the new modeled language features? And after discussing it, actually at some length with the Azure Data Factory team, we all came to the conclusion that it probably made sense to focus on V2 and let those who are doing V1 code or have to stay on V1 either continue doing it as they were before, or use this approach that I'll show you very briefly. So this is an approach that's actually described in more detail in the blog posts that Megan has put together. And let me just bring this Visual Studio window over. There we go. And this is in Biml Express. Basically, if you want to do, and this applies to any output that the Biml compiler doesn't fundamentally support. The Biml scripting language isn't limited just to scripting Biml, right? What most people have seen are things that look like this, right? Where I have Biml in connections and the connection underneath, and I could do like packages, and under packages I could have like a for each loop and create a package for each one of the tables in my source system, or other things like that. And that's a great way of using it. And then if I generate my packages, I get all the packages that are scripted out in my Biml code. But you can also use Biml to generate things that are not Biml at all, right? So here I have the ability to create, with my scripts here, I have the ability to create just this Biml script that I'm going to call that takes a table and will then create a data set for this in the ADF JSON. So this is V1 JSON, and basically what we're doing here is saying I want to create for each of my tables an on-premises SQL Server data set, which is of type SQL Server table, which connects to my on-premises SQL Server link service that has a structure as defined by the columns in my table, that has a table name specified is my only type property that's required, and then has some availability and potentially policy or whatever information I might like to have there. And I can do that as well for if this is a pipeline that is going to copy from an on-premises system to a blob data set. I can do the same thing here with my blob data set. I can say, here's my blob for my table, here's where it's going to be located, etc. And then I can have SQL Azure data sets if I'm going to SQL Azure through blob storage. And here's more or less what that looks like. And then I have a pipeline that will just go through and create a copy activity for each one of those tables. And that copy activity will go from my SQL source into my blob sync, and then from my blob source into SQL sync for SQL database. And I'm going to go ahead and zoom in. Sorry about that, guys. Got a question about making the code a little easier to see. So this is all very straightforward and something that you can do today in BimlStudio or Biml Express. And as I noted, there are some resources online that go through kind of like the whole process of figuring out how to script these things as part of a larger workflow. But the way you execute these, because you're probably looking at this and saying, okay, it's great that I can have use Biml script code nuggets and make this stuff work. But two questions: one, why? And two, how do I actually get the JSON out? So the why is that we have the ability to use all of the utility methods that we're already familiar with in Biml, things like go read my source database schema and get the information out so I can very rapidly use these code nuggets to, for example, specify the structure of a data set, right? I don't have to go and write ADO.NET code or do anything unusual or anything that I'm not already very intimately familiar with in order to actually do the scripting. Plus, I have the scripting tool already installed in my Visual Studio, or if I'm using BimlStudio, I already have that. So it's very convenient to be able to use this tool chain that I already have, and as you can see, the scripting is not actually all that difficult to do. It's fairly straightforward. So how do I get my JSON out of this? Well, we have to have this one sort of central file called the ADF writer. And this file will say, go ahead and connect to my source system. This is essentially doing staging, right? Connect to my source system, go and get the schema for it. Then for each of my tables, I do, and here's the trick to it, I use system.io.file.writeAllText, right? Very straightforward. I just say write all text. Where do I want to write it to? I just point it to the my target folder and file name. I construct the file name, and what are the contents of that file going to be? Well, whatever is returned by my call Biml script. So I say call Biml script on the file that has my code nuggets in there for the JSON, and I pass it in that one particular table. So even though it's a Biml file that I'm calling, what I'm doing is writing the contents of that, the output contents, into a JSON file. So when I do that, I can, when I have that pattern, I can of course do it for all of my different data sets. And I already had a gateway and the links, a few link services defined, and I'll just go ahead and write those out directly as well. And then finally, I write my pipeline. So if we want to see how this all works in practice, I can open up this Biml in the cloud folder that I have, which is currently empty. And then I just take my environment file, which is nothing but a connection string, and ADF writer, and then I generate my SSIS packages. And it takes a moment because my source database has more than a few tables in it. And what I'm going to get is a large number of JSON files. There they all are. Right? So if I wanted to look at any particular one of these, let's say my blob for addresses JSON, I'll go ahead and I'll open that with VS Code. And that's what that one looks like. That one's pretty straightforward. Some of them will be more complicated. And my pipeline is quite large, 118K. And this is, if you're working with V1, really like almost like a lifesaver in terms of the amount of effort that you have to expend. I mean, imagine having to write all this by hand and then tracking carefully, when there were changes and other things that you needed to do. So this has saved people a ton of time already. But it's not great for a lot of reasons. One, I mean, I have to use this effectively, this hack. This hack, by the way, if you want to call it a hack or a workaround, or all kind of, I guess, depends on your perspective on how nice this pattern is. This is also useful for anything else you might want to do with your Biml code where you need an output file that we don't natively support. So if you ever want, like, as a build target, right? So if you ever wanted to have your Biml generate a CSV, you could totally do that, right? Have it spit out a CSV in a Biml file, do a call Biml script on it, pass it in whatever the source for that CSV is going to be, and then just use file.writeAllText to write it out. If you wanted to write out SQL scripts that were custom and you wanted to persist them to a .SQL file in a location of your choosing, you could do that too. If you wanted to write out MDX script, you name it, whatever you want to generate, you can generate using this approach. Basically, as long as it's text, and even if it was binary, you could do that if you wanted to. Though the benefits would probably be lesser in that case. So while we can do this, and people have been successful with it, this is still awkward. For one thing, JSON doesn't work particularly well with code nuggets. It's okay. I've definitely seen more difficult to read and work with code, but it is definitely the case that our scripting syntax was designed so that it would layer in better with XML, right? And when we then look at trying to layer it in with a fundamentally different type of format, it just doesn't work as well. It works, it's just more difficult to read and more difficult to maintain and track. So that's one issue with it. The other issue is that we don't get that sort of integration benefit that we get elsewhere in Biml. Well, I think a very nice thing about Biml is that, whether you're looking at the relational side, or you're looking at the SSIS side, or you're looking at SSAS multidimensional or tabular, or you're looking at connections or other things like that, you can always use the same syntax, the same language. You can share assets, right? I define a connection once, and I can use it across everything. I can use it across analysis services, integration services, relational, etc. So you lose that in a very real way, right? I can't just reference a connection here any place. Just as one example. And you also lose the ability to get the object model out, right? One of the most powerful features of Biml is that I can have a scripted file that generates a whole bunch of Biml assets, and then use the object model to access those assets through the API and script out further things in later steps. You really don't have that at all here. I don't have an AST ADF dataset node that I could go and grab properties off of. Certainly not easily. So this is deficient in a lot of ways. So we wanted to solve that problem, and the way we solved it, completely modeling all of Azure Data Factory v2 in Biml as first-class concepts, where there's a new root object called the Data Factory, and inside Data Factories you can define everything you need. Before we jump into exactly what that modeling looks like, just for those who have used ADF v1 before, which was a fairly large chunk of you, and who might not be familiar with what's changed in v2, hopefully I'm not the first bearer of bad news, but there is good news and bad news. The good news is that the stuff in v2 is very promising from a design and implementation perspective. It is setting up ADF as a platform to go in absolutely the right direction as a general purpose data integration platform. Very excited to see what the changes are. Unfortunately, in order to get there, they had to pivot a bit, because when you look at v1 was really good at what it did, and what it did was tumbling time window data slice integrations, and particularly data movement. Did it very, very well. But that is a relatively small piece of the overall data integration world, right? Of all the types of tasks that you need to perform in data integration, tumbling time window, data slices, probably less than 10% of the work that happens in data integration all up. With modern data warehousing and stuff happening in the cloud, that number maybe goes up a little higher, but certainly with more traditional approaches, it's at most 10%, probably less. So they had to pivot a fair bit in order to extend the platform capabilities to do all these other things well, in addition to tumbling time window. So in order to do that, here's some of the things that are new. They have more connectors and activities. That's great. It's no breaking changes there. It's just additional stuff. The first really major breaking change that you have is a completely fundamentally new expression language redesigned from the ground up. So the old expression language, you would have like this $$ at the beginning to say this is my expression delimiter, and then you had some system defined parameters or variables that you could access about, like what was the slice time start and the slice time end and things like that, so that you could do text formatting on the names of maybe CSV files that you were writing into blob targets. But it was fairly limited in terms of what you could do, and that was a known issue. And when they looked very carefully, like how should we be designing the next generation language, should we extend it, should we start over, they decided that because so many other breaking changes were also going to be taking place, that changing the expression language wasn't going to be the one straw that broke the camel's back in terms of making things incompatible. So they went ahead with that, and the new expression language does have a lot more capability and a lot more headroom as well, just even the way the syntax works. So they have a brand new expression language. All your old expressions won't parse anymore. They have to be completely replaced and handled differently. The second thing they did is they added in triggers, which are a very powerful concept. Previously, the only way you would be able to trigger a pipeline to run was through your data set having a new slice available, essentially. Now you can trigger pipelines to run whenever you want to. They have a tumbling time window type of trigger, so that you can get the exact same semantics that you had previously in terms of when your pipelines will run. But you also have things like a schedule trigger, where I can say, I just want this thing to run every 10 minutes, or every hour, or every day, or every month, or whatever. And with some of the new activities that are available, the ability to have a recurring schedule-based trigger becomes a lot more important as well, because some of those new activities are things that really don't have a direct connection to a data set, or certainly not a data set slice. Integration runtimes are new. You may have heard of integration runtimes in the context of integration services and being able to run SSIS packages in the cloud on top of the SSIS, the Azure SSIS integration runtime. But integration runtimes are more of a general purpose idea for essentially like, where is your integration code running? Whether it happens to be SSIS or ADF is almost irrelevant. It is essentially a container for all the properties that define where execution takes place. So what you used to do with gateways in V1 that were entirely a gateway concept now happens with integration runtimes, where you can configure an integration runtime or more than one integration runtime in Azure. You can have SSIS integration runtimes, ADF integration runtimes that you manage separately in different data centers. You can also have them local, and you can have them all interoperate with each other in nice, convenient ways. And the way you say which integration runtime you want to have, there's this new connect via property that's available on your link services that let you specify which integration runtime should be used. Now, because of these new features and some others, there had to be some removed features because it kind of didn't make sense anymore, or things that were kind of like first-class citizens in ADF v1, since it was all about tumbling time window, where now the tumbling time window is less of a focus for them, shouldn't be there anymore. So, for example, having a data set policy has been removed from data sets because you don't specify that there anymore. That's something that gets specified more at the trigger level now. Another example of something that's removed is scoped data sets. There's no such thing anymore. So if I wanted to create a data set that was scoped to a particular pipeline, I could do that in V1, and then that data set would only be available to that pipeline, not available to any other pipelines. It made coding a little bit easier too, because you could specify everything locally in that one pipeline file. Or not everything, but most things locally there. You'd still have to do the link server. That gets to one of our abstractions too, which I'll talk about a little later. We kind of re-added that feature, not the scoping part, but the local definition part, because it's very convenient for scripting to not have to break out things that are iterating over the same loop into different files. Okay, so that's the stuff that's new in V2. So when you see some of these things that we've modeled out, just be aware that that's, if they look unfamiliar for the V1 users, it's because a lot's changed. And I'll go ahead and address it up front because I'm sure there'll be questions about this. You know, is this going to be free in Biml Express? The long-term answer to that is that that's our plan to make this available for the current Biml Express audience. The short-term answer is no. You have to use BimlStudio for it. The reason for that is, you know, it isn't any sort of hey, we want to try and lock this down. It's really more of a question of how would we get this into Biml Express in a way that makes sense. And that comes down to two issues. I'll actually take them bottom to top. Let's just assume we wanted to use the Biml Express add-in as it currently exists. That currently hooks off of the SSIS project system, the DT Proj project system. So there really isn't any place to kind of hang that off the SSIS project system, because the SSIS project system doesn't have much in the way of files that like file hierarchies and stuff like that that can be managed. So if we wanted to put a whole bunch of JSON files in there, like you just saw, in order to auto-generate, it would have to be a flat list. You can't have like subfolders and stuff. And that's just one of many issues. We went through and actually prototyped some of it out, and it just does not work all that well to have to do that integration. We may have to end up actually implementing our own project system, or going along with some of the things that are currently implemented in the Data Factory tools for Visual Studio extension. So that's something that comes back to the ADF product strategy. We're very closely aligned with the ADF team. We talk to them regularly, and we discuss some of these strategic issues around like how do we package this up so that it makes sense for delivery. And that's presently a challenge, but we will work through the challenge, and as soon as we do, we'll have we'll tell you all about it. But we have to get through those sort of technical hurdles first, and design hurdles. So what we've done in the language, and you'll be able to see the language right away in BimlStudio, is have first-class language elements. So we have a data factory top-level item, which contains pipelines and data sets and linked services and triggers. And then, of course, under pipelines, you could define activities, and there are parameters that are definable on your pipelines and also on triggers. And because we've added this as an abstraction, also on activities, and we do promotion for you automatically. So you start adding in these language elements. I figure I'd just make a quick list just to give people an idea of kind of the surface area. This is just like with integration services, 100% surface area coverage. So everything that you can do in Azure Data Factory, you'll be able to do here with Biml as well. I'm going to show just in a slide a real quick example of the corresponding Biml for a given small ADF JSON file, but then we're going to spend most of the rest of the time on this actually looking at code samples directly in BimlStudio and seeing how that code gets generated. So here's some ADF JSON for V2. I chose a linked service here because, well, aside from the connect via, this should look exactly like what your V1 code would look like. So here we have in our ADF code a linked service, which is named Azure Storage Link Service. That's just a name that we can assign. It has some properties. One of the properties is the type, which is Azure Storage. And then for the Azure Storage type, there are some type-specific properties, right? So basically the properties that are available to all linked services are listed here under properties, and there's not that many for linked services. And then once you've said what my type is, now there are some properties that are going to be specific to the type of linked service that I'm defining. In this case, I'm defining a connection string, and connection string can even have things like, well, certain properties are defined as secure strings, and they just have to be. And the way it works in the JSON is you say secure string, and then you say what the value is. And the reason why you say secure string is that tells ADF that when they store this, they're not actually going to store this text directly. They're actually going to encrypt this data for you when it lives in on their servers. And then connect via will just say, hey, which integration runtime should I reference? And then you actually for various reasons, have to say, well, what is the type of this connect via? Well, it's an integration runtime reference. You'll see some of this in ADF where sometimes there'll be stuff like, well, why do I have to say type secure string? Why do I have to say type integration runtime reference? Can't speak to exactly why some of those things are happening. In some cases, I don't know. In some cases, just not at liberty to share, future plans or design decisions that are still in the works. But when I design things and require you to have a property where it's a required property and there's only one value, the reason is because I expect there to be future values that you might be able to put in there at some point in the future. So instead of having it not be there and then having this be the forever default, you actually force it so that a value that you want to be required gets to be required. And it might seem tedious, like why the heck do I have to put type equals integration runtime reference and it's always that and I can't ever put anything else? Well, it's because in future versions, my guess would be, as someone who's designed languages and file formats, that there might be additional options at some point in the future. And not saying anything specific about any one of these, but just in general, you'll see a fair bit of that in ADF JSON today, where there's probably a couple dozen properties that are like that, where you just have to specify them. So what do we do in Biml? Well, we have a bunch more flexibility in Biml than you have in JSON. Because it's an XML file format, you have more flexibility in terms of writing. So when I look at the JSON here, there is no type in a JSON object, right? For those who aren't familiar, JSON just stands for JavaScript Object Notation. This is actually a fragment of JavaScript code, right? If I were to throw this into JavaScript and put a var obj equals in front of this, I basically just, and then a semicolon at the end, I've just defined a JavaScript object statically that has this nested property structure. So because it works like that, and because of the way JavaScript works, you don't actually have types associated with these things. The types are dynamically defined, at least in the way the JSON is almost always structured. So I can't say, like, at the top, hey, I have an Azure Storage link service, and say that's the type. And then underneath it say, here are my properties that only Azure Storage Link Service has, I have connection string equals this and something else equals that. And you could try and make it work that way, but I've seen those sorts of designs, and they're very cumbersome. This is a very standard and well-accepted approach to doing JSON object model designs. But in XML, we have a very different sort of structure, right, where I have an element that I'm defining my properties underneath, and we get to hang everything off of an element. In doing something like saying just linked service element and then having a type where I specify the type and then having the properties like change out from under it, that not only would that be super awkward in XML, it would be hard to even to get work to work properly with XML parsers. So we took a very different approach, and it is a very time-consuming approach to model things out this way, but I think it's worth it, where this turns into this. So I've done some shorthand here. It's the link services. Oops, there's a mistake here. Sorry about that. You'll see this live in just a second. The mistake is basically just that we don't have the link services untagged. But you can define link services and say, I'm going to have an Azure Storage link service. And now because we know it's an Azure Storage link service, this is its name, this is its connection string, this is the connect via information. That's it, I'm done. I don't have to worry about having like type properties and validating that they're the correct subset of type properties and whatnot. I can code this very much like I would in if I was doing SSIS packages, and you get IntelliSense for a very good IntelliSense experience out of that. In fact, a much better IntelliSense experience than you would get with any sort of a JSON editor using the type and type property approach. So let's actually jump in and see what this looks like in practice. So here is BimlStudio, and what we have here is this one big file, and this is kind of neat, right? I'm going to do in this one file, I am going to define from an on-premises SQL Server to Azure Storage, and then also Azure Data Lake, right? To show you just both examples. So you can do both both types of pipelines all in one go without having to worry about anything, without having to worry about like multiple files and stuff, just in case you had both pipelines. So you can see I have data factories. My data factory is named Data Lake Loader. I could have called it just ADF Loader or whatever. I have some link services underneath that. My SQL Server link service has a connection string associated with it, an integration runtime connect via. My Azure Storage has a key associated with it. I'm just going to move that over in case anyone's taking notes on the key. You didn't get all of it. Haha. We have our Azure Data Lake with some subscription and other connection information, and we also then define our datasets. Now our datasets are going to be defined for each of our tables. Just a quick note on the making the text a little larger. Just a quick note on datasets. You have some additional capabilities in Azure Data Factory v2 around control flow. So some of those new activities that have been introduced are these like a for each and a do in until, which is basically a do while loop, and you also have in if else, or they call it an if condition activity. So you have a lot more control over being able to say, let me take these parent group activities like a for each, provide an expression that will give me a list of items to iterate, and then for each of those items I'm going to run some collection of child activities. So you can do things like, and they also have a get metadata activity, which is kind of like get database schema. So you could do things like say, hey, I want to go and get each table in my source system and then run a set of activities for each one of those against data sets that have been configured for each of those tables. So some of this that you're seeing now is absolutely essential. There was no other way to do it in V1. In V2, there are some options that are built into V2 where you wouldn't have to script out for each table, create a new data set, but it's still not a general purpose where you're going to be able to do that for every single scenario you might want to. So this is still a pattern you're going to see fairly often in V2, at least for the time being. And as things change and more features are added, we'll of course start evolving our samples in side by side with the additions to the platform. So here we're doing our SQL Server data set, which is our on-prem. So then we get this nice feature where I can just say, hey, link service name, and I just do a reference to SQL Server on-prem. So we're now just getting some of these benefits that I mentioned from being part of this integrated Biml infrastructure, and so I can just reference things that I'm defining elsewhere. So I'm going to reference my SQL Server on-prem. I'm going to define my structure. Here's another thing that's nice. You see our data type. This data type is the same data type that we use everywhere else across Biml, and we'll do the auto conversion. In ADF, they use system.type. What we use is based on system.db type. So the next thing you'll see here is just our Azure Blob. We have text format. Text format, we're saying it's text format, but we're using the default values in there. You'll see that I get all my IntelliSense on exactly what I can do inside a text format, and all of this works very nicely. And if I were to say, what's one of these where this one's not as good and there's no enums in here that I'd be able to do, but we have enum completion and everything else that you would expect. Here's one. Compression type. So if I wanted to say that it's compressed, here are all the different options for how I can compress and decompress this file. And you'll see that we have code nuggets littered around here just like we normally do. I have a folder path which is going to be the table name, and then I also have, we can mix in ADF expressions. So this is the new expression format for those who haven't seen it before, using a concatenation function to say I want to concatenate the table name, and then take the URI component of the executed date time, which is a parameter that we're going to define in just a moment on the pipeline. So nice thing, pipelines and other ADF pieces like activities have their own parameters that they define and fill in, and you can access those very much like SSIS has system parameters or system variables and user variables. Well, you can have they have system parameters in ADF, and they also have these user parameters. And actually, let me just skip ahead and show you. We just define it down there, right? So here we have an executed date time, and we just use it in our expression. And you can see how different this is for those who are using ADF v1, just how different this is as a syntax from what they had before. It's something that is going to require conversion if you have your v1 stuff. And I know that the ADF team is very interested in making that conversion process as painless as possible. So it's something that you can follow up with them on if you have questions about it. Or even me, if you have questions about conversion, it's something I know a fair bit about. So if you have questions, I'd be happy to answer them to the extent that I can, at least. And then we have our pipeline. Our pipeline, we are saying for each of the tables, I'm going to have a copy from the source to the sink. You'll notice I'm referencing my data set, as one does in the copy activities. And this is something that we've modeled out. For those who are familiar with how copy activities work, you have a source and a sink. And those reference a data set, but then also have the ability to specify additional arguments. So with this single data set, I could, for example, say, hey, that table name that I specified? Well, just don't do a select star from the table name. Let me clean that up. Don't just do a select star. Actually, I want you to run this query, or I want you to run this stored procedure and supply these parameters. So we support all of that. And for blob sync, the parameters, you can say copy behavior, like what you want to do with preserving hierarchies and whatnot, or flattening them out. And then we have Azure Data Lake. You can see works very much the same way. So these just reference, and this is something that is a slightly cumbersome sometimes from a design perspective when you're designing your pipelines. Which of your properties live on the data set itself versus the source of the sink, and it's just something to get used to and understand where those are. Usually people don't have too much of a problem with it. But as you'll see, the way we've done this is because there are different properties on each of those, under the copy activity, you just have to pick out what your source and what your sink are. Right? So I'd say, oh, well, if my source was, and I'll get an error if I do more than one, but if my source was, let's say, Azure SQL Database source, then I'm going to get a different set of options potentially than if it was SQL Server. And actually, in this case, I get almost identical options, but you get the idea. So once I have all of this, all I have to do is a build, and we do have a couple of build options that we're exposing. Let me do the build first and show you what this is like, and then let me just actually open this up in Windows Explorer, and I'm going to go here to my output and just clear it all out so that you can see we're doing everything from scratch. We do have a clean output, but I figured I'd show you that. and then I do a build. And this is a live file. It's actually just called Biml file 1. You see the blue dot means it's live, and it's been a successful build. So if I go back to my output window, I now have my data factory that has been created, and my data factory, they're using my data sets, link services, pipelines, etc. Now we do have a few different options here in terms of how we do the builds. And this is something that I'm sure folks who have worked with ADF before have found both some level of appreciation and some level of frustration with, because it is a double-edged sword. When you look at these files that get created, for example, this data set right here, when you look at this, what we have is something that doesn't even really say that it's a data set, right? You can tell that it's a data set because if you go and find the type, you can say, oh, well, I happen to know that Azure Data Lake store file is a type name that only can be used with data sets. But it's certainly possible that you would have a, but it is also the case, rather, that type doesn't always live directly underneath here. Sometimes type is under properties. So you just can't do a very simple sort of inspection of a file without actually doing a decent amount of parsing in order to figure out what type of file that is. So in order to then deploy this, right, I'm going to have some PowerShell scripts that iterate over all the files in a directory and say, I need to call my PowerShell commandlet to deploy this. That's all fine, but how do I know which PowerShell commandlet to call? Because the PowerShell commandlets, there are different ones for each entity type, right? I have a set pipeline, I have a set data set, I have a set link service. So how do I pick which one of those to use? Well, normally what people will do is use some sort of file system hint to say what this thing is, right? In our case, for this default build, we have data sets and link services and pipelines, so basically you just iterate over the data sets collection and deploy those, iterate over these, iterate over those. Some people prefer to put it all in one directory, especially for smaller builds, and prepend dataset underscore or put underscore dataset at the end or something like that. You can certainly do that if you want to as well. And we have a few different build modes. It's just under the project settings where you say, here's the version I want to do of ADF. Then you just have a couple of checks to say, do I want to use basically what's my naming format look like for the files that get spit out. You just have a little string format that you can fill out essentially. Excuse me. So we provide some customization there. This is something that we're very open to feedback on. If you have had a fair bit of experience in handling these sorts of deployments, and you have some ideas about different ways that we could manage, or maybe novel approaches to managing all the different files and how they get and how they get written out to the file system, things that we might not have considered, very interested in hearing about it. So. That is the high level here. This is something just to explore. We're going to be putting a public preview out of this fairly soon. Anybody who wants to be part of the public preview, let me see what the best way to do that is. You can go ahead and put in a question that just says public preview and nothing else, and I'll make sure that we put you on the invite list. Alternatively, for those who are listening to the recording of this, if you go on Twitter and just send a direct message to @BimlScript saying public preview, please, we will make sure that we send you an invite to that, so that you can try this out and make sure that it's working for your ADF scenarios before we ship the final version. So that's a high level of what this looks like. It's all really quite straightforward. The last piece of this that you would have then is writing your PowerShell scripts to essentially just iterate over the code, and I'll pull one of those up in just a minute. But before we do that, I am going to just show you a couple of the things that we have for. Let me go back into this. Biml Extras. So this is something that is risky to do, as I kind of made reference to that earlier, where there are things that we can see in Azure Data Factory that make sense and that are probably going to end up in some version or another in future versions of the native platform. But just because they're going to end up in future versions doesn't mean that they're not useful today. So what are some things that we can do to try and make those features available today and have a smooth transition where when some version of them or version of the concept at least makes it into the native platform, that you get a nice smooth transition. Having a great relationship with the Azure Data Factory team is great for managing that, because we can show them the abstractions that we're putting in there, make sure that they're not totally incompatible with what they have in mind, and then make any tweaks to ours that we might need to in order to support the direction that they might head in the future. This is what we're currently targeting for abstractions just in the first release, and this is someplace I think we're going to be investing pretty heavily. One is the dependency mode on all containers. So for those who are more familiar with Azure Data Factory v2, you'll know that control flow features are also things that have been added. Not just the activities that I mentioned earlier, but also the ability to do something kind of sort of like precedence constraints in SSIS. They're not as powerful yet as precedence constraints are, because you can't have them with an expression. So like in precedence constraints at SSIS, you can have both what is the completion mode, right? Complete it, failed, succeed it, and then you can also apply an expression where it will only take that path if the expression evaluates the true. So they don't have the expression part yet on dependency mode, but they do have the completion part. So for Azure Data Factory, it's succeeded, failed, completed, or skipped. Skipped is if it didn't get taken on some other path, which actually is a very neat sort of addition. When you're scripting, though, as folks who've written Biml code before know, it can be a real pain to keep track of, hey, what was my last activity in the loop, so that I can go, if I want these to run, let's say, linearly, what was my last activity in the loop so that I can create a depends on property and hook it up. Oftentimes in scripting, what you want to do is create things like, let's say I want to run batches of 5 activities, one right after the other, but each batch can run in parallel, or something like that. We have these two features that allow you to do that. The first is dependency mode, and the second is group container activity. So group container is just an abstraction that says, here's a list of activities that I want you to run, and that's it. And it actually translates to effectively nothing in the output code. There is no group activity yet. What that means is you might have the group activity because it makes scripting easier to organize in your Biml, and we just emit it as essentially nothing. We take the child activities and just emit them directly. But with dependency mode, you can say, and by the way, I want you to automatically create depends on properties for all of my activities so that they all depend on each other linearly, just like with precedence constraints and constraint mode equals linear, or linear on completion, or linear on success. Same idea. But in combination with the two, if I, for example, had a group, and that group had a dependency on another group, what we do is we actually look at all of the dependencies within the group and figure out the dependencies that have to be made from the activities in one group to the activities in the second group, so that you've just simulated the behavior of the group depending on the other group. But you do that in a very easy way in the Biml, and we do the hard work in the compiler of figuring out what all those dependency lines need to look like and spit it out for you. Hopefully in the future there'll be something like a group activity, so we don't have to do that, and we can just spit out the group activity containers. For now, that's how we're managing and making that feature available. We're also doing things like promotion. Right? And there are two features that have promotion: local data sets and parameters. So parameters are defined on the pipeline, but a lot of times you're only going to be using it within a particular activity or something like that, like within a particular copy activity. So we allow you to specify parameters in many different places, including on activities, and then we will automatically name them and promote them to the pipeline level and let you know if there might be any name collisions that you have to be worried about. We also do that with datasets. As I mentioned earlier, there was a dataset issue where, or not so much an issue, but scope datasets were a feature, and that's no longer a feature. While we agree that that probably shouldn't be a feature, given the current design direction, we still see the value in having locally defined data sets within a pipeline when you're in a scripting situation, right? Much like we saw earlier. So we allow you to define data sets locally underneath pipelines, and then we will just promote them up and emit them as if they weren't, and make sure there are no name conflicts or anything like that. So these are the 4 things that we're tracking for the first version. Number 1, number 2, and number 3 or 1, 3, and 4 are quite easy. And actually 2 is pretty easy too, but the combination of 1 and 2 working together is a fair bit of work. So that's why we've limited it just to these 4. We also don't want to go over the top and do things speculatively. We want to do things that we know are going to be useful based on our own experience with ADF. If, as I said earlier, anybody has recommendations for things that we should also be looking at in terms of these additional abstractions that we can add to ADF Biml to make it easier for common scripting scenarios, we're very much interested in hearing your feedback and adding whatever we can in whatever makes sense for a general audience. That's really all I have there. If folks would like to see what the PowerShell scripts look like, I'll just pull up a PowerShell script very quickly, because that was in the abstract, but I think it's probably not the most interesting part of this. But if I pull up the PowerShell script, there it is. So basically we have stuff that looks like this, where you can say, I want to, this is actually our remove script, I want to clear out existing data factories that I may have created. We also have the ability to do things like, let me open this with code as well, going through and checking to see whether or not we have any activity runs in place, and in managing them through like spitting out notices. This would be more of our run pipeline. So all of this is relatively straightforward. You just install the PowerShell Azure RM PowerShell extension, and then you get all of this available to you. Note the V2, so there's a completely new set of PowerShell extensions that you can use. I can say, I want to create a data set. Here I'm creating a link service. Here I'm creating an encrypted credential. Here I'm creating an integration runtime. So actually I'm getting an integration runtime that I may use later. Here I'm setting a pipeline. And then all of these can very easily be put into for each loops as well. So if you wanted to have for each loops for the purposes of iterating over all the files in the datasets directory and calling a set dataset on each one of them rather than listing them out, very easy to do with PowerShell, and that hooks in nicely with automation workflows in BimlStudio in particular. Right? You can just have as a second build step if you want to. Hey, once I've built these things, go ahead and deploy them as well. So that's the high-level overview of what's coming in Azure Data Factory v2. Hopefully, I struck the right balance in terms of explaining to people, what was new in v2 and how we were doing the modeling and what was different between v1 and v2, so that everybody got something useful out of this. If you have any questions, there didn't seem to be. There's a bunch of public preview requests. There's a couple of requests in terms of zooming in on code, a bit of feedback about v2 only being a good choice, but no questions actually. Does anybody have anything they'd like me to address? Okay, seems not. Thanks everyone for coming. The public preview, as I said, will be coming out shortly. There's actually a question about can we have a link to the PowerShell scripts demo as well? Yep, absolutely. That is going to be included in the when we post the recording of this video. It'll be linked side by side with the recording. It also will be included as one of the samples. We'll clean it up a little bit and include it as one of the samples that sits in the distribution folder for the public preview, and of course we'll blog about it and everything else. I know that there are a couple of folks in the Biml Hero community who are very eager to blog about all this as well and have some of their own code samples. So you'll be seeing that coming in the next couple of weeks. We asked them just to hold off on it until we had a chance to get the public preview out, so folks could actually go ahead and use it. So the question about the features in VS 2015 and 2017, everything Biml Express related is going to be 2017 in the preview. It's all part of the same preview. We simultaneously ship all of our products. 2017 is addressed. For those who have questions about 2017 versus 2015 and installing Biml Express on 2017, it's a more general question, but I know it's a common question. There's a breaking change that was made in the format for V6 manifests. So V6 is the Visual Studio extension packaging format. The manifest files, you can either have them work from 2010 up through 2015, or 2012 up to 2017, I think. But if you want, you can't have one v6 file with a single manifest, or even multiple manifests, because you're not allowed to have multiple manifests. You can't have one v6 file that actually works for all versions of Visual Studio. So we have to ship 2 different v6 files, and that's having the 2017 one will be part of that upcoming preview and full release. Okay, thank you everyone. I'm going to go ahead and stop the recording, and I'll hang around in case anyone has a couple of additional questions that I can address. I'll do the rest of them from here on out in text. Thanks again.